So in this video today, we're going to be looking at the relationship of the mass of one substance to the mass of another substance in a balanced equation. So we could know the mass of our reactant and want to know what would be the mass of our product, or if we know the mass of one of a reactant, what would be the mass of our other reactant, or even if we know one of our products, we could figure out one of our reactants from that. So basically, we're going to have out your double mole diagram or your expanded mole diagram, this one here, and we're going to be going straight across this diagram. So we're going to go mass of A to moles of A, and A is always going to be our given. Then moles of A to moles of B, and B is going to be our find. Then we're going to go moles of B to mass of B. So the steps for our mass to mass relationship is where we change the mass of A, our given, to moles of A to moles of B, moles of B to mass of B, which is what we're trying to find. In our first balanced equation, we're looking at breaking down sodium chloride into its two elements, sodium and diatomic chlorine. So we're going to determine the mass of sodium chloride that breaks down or decomposes to make 355 grams of diatomic chlorine. So make your list of given and find. So we're given 355 grams of diatomic chlorine, and we're trying to find the mass of sodium chloride. So I label these A and B. So we're going to start with your given. So we're given 355 grams of chlorine. If we want 300, or if we want grams of chlorine, to cancel, that's going to go in the bottom of our equality. And looking at your mole diagram, we go from mass of A to moles of A. So moles of A will go in our problem right here. So since the substances are the same on our or within our equality, we will put a 1 right here. Where did the 70 come from? Again, we went to our periodic table, we found the mass of chlorine, and we rounded it to 35. We have 2 chlorine, so 35 times 2 gives us 70 grams. So 355 times 1 divided by 70 is 5 moles. So we take our number of moles, so we're going to go moles of diatomic chlorine to moles of our sodium chloride. So looking at our double mole diagram, we've just finished step 1. We're going on to step 2, which is our bridge step, where we go from moles of A to moles of B. So if you look at our problem, our number of moles are not the same. We use our equation coefficient according to what it shows on that mole diagram. So where did the 2 and the 1 come from? They came from right up here. So here's our 2 for our sodium chloride and the 1 for our diatomic chlorine. So again, if we wanted moles of Cl2 to cancel, that goes in the bottom, and moles of sodium chloride will go in the top. So 5 times 2 divided by 1, you get 10 moles of sodium chloride. Now we're going to go finish up our second step, and we're going to go on to our third step, where we go from moles of B to mass of B. Moles of B to mass of B. And if we want moles of sodium chloride to cancel, it will go in the bottom. And then mass, because that's the box we're going to, will go in the top. Notice our substances are the same in the top and bottom of our equality. So we're going to put a 1 here for our number of moles. And the mass, well, we look up the mass of sodium, the mass of chlorine, mass is 23, chlorine is 35, so that's where the 58 came from. Only this middle step here is where your number of moles may not be 1, because notice again, your substances are different. But in this step, our first and our third step, your moles are the same, or your substances is the same in both the top and bottom of your equality, so your number of moles will be 1. So you take 10 times 58 divided by 1, and you get your final answer of 580 85 grams of sodium chloride. If you like to have it broken down where you just do 3 one-step problems, you're more than welcome to. However, I like to teach it where you're working with one 3-step problem. And it's a little bit easier where you can see how your grams of chlorine, they cancel. So then you go moles, moles of chlorine, they cancel. Here we go. Here's your bridge step, moles of chlorine, 2 moles of sodium chloride. Then if you want moles of sodium chloride, it goes in the bottom so it can cancel, and you're now to your mass. Just like before, you're going to multiply everything on top, multiply everything on bottom, divide to get your final answer. So let's look at our first practice problem. Again, I've given you your balanced equation. We have calcium hydroxide plus sulfuric acid is making calcium sulfate and water. And we want to know how many grams of calcium hydroxide will react if we have 29.4 grams of the sulfuric acid or H2SO4. So let's list our given and our find. So we are given, let's use 2 different colors here. So we're going to use blue for given. And what are we trying to find? We're trying to find our mass of the calcium hydroxide. And our find is going to be B. So we're going to always start with what we're trying to find. So question mark, grams of calcium hydroxide. And this is so important that you write these either in 3 one-step problems so you know that you're canceling and you're going from the correct substance to the next substance. Make sure you also label your substances so you know you're putting them in the right order. And that's going to equal what you're given. So we're given 29.4 grams of H2SO4. Let's set up your first equality. If you want grams of H2SO4 to cancel, that's going to go down here in the bottom. And looking at your mole diagram, we're going to go mass of A to moles of A, or mass of H2SO4 to moles of H2SO4. And since the substances are the same in our equality, we're going to put a 1 here for our number of moles. And we go to our periodic table, and the mass of H2SO4 or sulfuric acid is 98 grams. So now your grams of H2SO4, they cancel out. You're ready for your next equality. So if we want moles of H2SO4 to cancel, that will go in the bottom. And looking at your mole diagram, we're at moles of A, we're going to go moles of B, or moles of H2SO4, to moles of your calcium hydroxide. And this is the step where we use our balanced equation. So it says go to your balanced equation. That's where we use our coefficients. And our number of moles may not be 1. They could be a different number. So our number of moles of H2SO4 is going to be 1. And our number of moles of CaOH2 will also be 1. Like I said, they may be different depending upon what your balanced equation's coefficients will be. Now we're at moles of B. And if you want moles of CaOH2 to cancel, that's going to go in the bottom. And looking at your mole diagram, we're going to go moles of B to mass of B, or mass of our calcium hydroxide. So since our substances are the same on the top and the bottom of our equality, our number that will go with our number of moles will be 1. And we go to our periodic table and we find the mass of calcium hydroxide, which is 74. So if you look, grams of sulfuric acid, they cancel, moles of sulfuric acid cancels, moles of calcium hydroxide cancel, you're left with your mass. To solve, you're going to multiply everything on top. So 29.4 times 1 times 1 times 74, and you'll get multiply everything on bottom. So 98 times 1 is 98. You're going to divide that intermediate answer, and your final answer will be 22 grams of CaOH2. Taking a look at our second example, we have sodium and water reacting to make sodium hydroxide and diatomic hydrogen. We want to know how many grams of hydrogen are produced from 23 grams of sodium. So make your list of your given and your find. So our given is A, and we're given, or it's going to represent A on our double mole diagram. So we're given 23 grams of sodium. And what we're trying to find is going to be B on our double mole diagram. And we're trying to figure out how many grams of hydrogen are going to be made. So we're going to start with our find. So question mark, grams of H2. That's going to equal our find, which is 23 grams of sodium. If we want grams of sodium to cancel, that will go on the bottom. So grams of sodium will go on the bottom. Looking at our mole diagram, we're going to go mass of A to moles of A. So that means we're going to go mass of sodium to moles of sodium. Since our substance is the same in the equality, top and bottom, we'll put a 1 in for our mole. We go to our periodic table, and sodium has the mass of 23 grams. So your grams of sodium cancel, you're left with your number of moles. If we want moles of sodium to cancel, moles of Na will go in the bottom. Looking at your mole diagram, we're going to go moles of A to moles of B, our bridge step where we use our balanced equation. So we're going to look at our balanced equation to find our number of moles. So for hydrogen, that's going to be 1. And for sodium, that's going to be 2. So again, in our bridge step, our number of moles may not be 1 because our substances are not the same in our equality, and that's okay. We want to use our balanced equation. This is where we're looking at that relationship between your reactant and your product here. So now your moles of sodium, they cancel. Now we're going to go moles of hydrogen. And if we want that to cancel, that will go in the bottom. To mass. So moles to mass. We go to our periodic table. Hydrogen has the mass of 1. Since it's diatomic, we have 2. And since our substances are the same, we put in a 1 for our number of mole. And our mole of hydrogen, they cancel out. You want to multiply everything on top, multiply everything on bottom, and hopefully you're going to see that you're going to get the answer of 1 gram of hydrogen because everything cancels out. 23 cancels, the 2 cancels, you end up with 1 gram of hydrogen.